Okay, so on Friday we started graphing the sinusoidal functions, and we talked about the properties such as the midline. So here it is in the pink, you can see this midline. We talked about the amplitude, which is me saying how much above and below do I have to go up and down. And the period, which is how much space it takes me to get through a cycle. Okay, so we left this blank, which was determine an equation. So here we go. Y equals, okay, ready? The amplitude needs to go into the front because it's a multiplier. Would that make sense? Usually you multiply things and they would go up 3 instead of 1. And I'm going to pick a cos function on this one. I wouldn't be worried about that right now. And then there's going to be a B letter in here. And then at the very end, you're going to have to write your midline. So we went down 1, so I'm going to write down 1 there. Okay, so amplitude, midline. That's where you put those in the equation. That's where you would always see them. And here's what we do with our B. You ready? Something you're going to have to memorize. Our normal cycle on a circle is 360 degrees, right? Or in radians, 2 pi. So 2 pi or 360, doesn't matter what language you're talking in, depends if you're talking in radians or in degrees, divided by B is what the period equals. 2 pi over B, kind of rolls off the tongue like that. 2 pi over B is the period. Okay, so we have this info. Our period was pi. So if our period was pi, 2 pi divided by what? 2 pi divided by what would be pi? So 2 pi divided by what would be pi? Did you pick 2? So therefore this has to be a 2. Sometimes there's a shift in that. Pre-calcers learn about it. I'm not going to do that in applied because it gets crazy. So if I have one, I would tell you. And what I'm going to do is I'm just going to negate this because of this. Where does a cos curve usually start? On a top. And where did this one start? On a bottom. So therefore I just flipped it around. Okay, so let's go into putting that together. Here we go. Looking at this graph. Let's do midline first because that's always the easiest. So -1 is the top. -5 is the bottom. What's in the middle of those numbers? -3. So midline, y equals -3. I'm always going to write y equals. And what is our amplitude? So that is this. How much am I going above it and below it? Doesn't matter which way, above it or below it. What's the stretch away? Did you write 2? And the period, how long does it take us to go through a cycle? So can you pick me a certain point? What do you want to do? Do you want to do a top point, a middle point, a bottom point? and it doesn't matter. So let's pretend I pick a top point. I travel, I travel, I travel. This would be me getting to another top point. So if I went from that top point to that top point, what is the space it took me to do that? Would you think that that took 4? You know what I mean? I'm talking about space. I'm not going to write 1 because that x value is 1. I'm saying what's the space. So the period is 4. The range. So how do you write range? Lowest to highest. So what's the lowest this graph would travel? -5 to -1 with squares. Okay, so I want you to fill in we're going to put some numbers in these spots now. So if we were to make an equation, what number went into the front? The multiplier in the front. So the multiplier would be 2, because that is our amplitude. What do we multiply by? Then there is a number at the end that you could add or subtract. So always on graphs, when you add or subtract, it moves stuff up and down. So what would you like to add or subtract at the end? Were you going to think subtract 3? Because that is our midline. It shifted it down. This really stretches our graph. And the b number is weird. So we're going to go 2 pi over b equals 4. Because our period is 4. So this little formula, 2 pi over b equals period. It's a little formula that I would suggest you memorize. Okay, here's what I'm going to do to solve this. I'm going to flip-flop those in a cross-multiply pattern. So 2 pi over 4 equals b. You can write that. For me, I'm just going to reduce. And put a pi over 2 there. Okay, should we check out our work with our calculator and see what happens? So this is the equation we made. We're going to graph that. So before I graph it, looking at that, what kind of mode would you think they're working with? Are they working with radians when they give you this, or are they working with degrees? And I'm going to pick radians because of that. Okay, so mode, I'm still in radian. I think that you probably will be because that was what we did last on Friday. Do you want a calculator? Okay. So y equals 2 sine, and then I think you're going to need brackets around the fraction there. If you could do the pi over 2 in a bracket. So then I actually ended up with a double bracket. And then we're going to check out our window. Okay, so if I want to match this, should we just do zoom 6 and it's just a 10 by 10? Is that okay? Zoom 6. And do we look the same? 0, -3. And then I went up to -1. I went down to -5. Yep. Look at that. So we did it. We found the equation that would match. Okay, next one. Okay, I like to do this on mine. I like to say, well, what do I have on the top? What do I have on the bottom? So 1 and -5. So now I'm working to think what's in the middle. What's in the middle of that? What did you get to for a middle? So if you always want to know a quick way, you can just add and divide by 2, because that's what an average is. That divided by 2, did you get to -2? Okay, so midline, y equals amplitude. How much space is there above and below? Be whatever the number is, it's got to be the same, right? Equal distance, 3. So that's our amplitude. So the range, -5 low to 1 on the top. Okay, period. What do you want to do? We could do like these two. We could do these two bottoms. I don't care. But at whatever point you pick, you got to pick the same point that it gets to. So I'm going to pick a low and then the next low and say how much space did it take me to go from a bottom to the next bottom. And I got 6. So that's our period. Okay, so ready? What would you put in the front multiplier spot here? Which number would go into front multiplying? 3 is the multiplier. The heights got multiplied. Cos what number goes at the end? Subtract 2, because we shifted it down 2 with the middle. Okay, the b. We have to do a little formula for the b. So 2 pi over b got me to 6, the period. 2 pi over b equals period. Switch and you can write that, or I just reduced it by 2 here. That's by 2 and that's by 2.
Would it be wrong if you're on 6?
You could write 2 pi over 6. You can write exactly that. It's fine. Okay. Again, I'm not going to teach you this or expect it to be on a test. Pre-calcers would have to know this. I'm going to write a -1 there. Do you even care to know why I'm doing that, or you're just... It's basically that I saw cosine. So cosine starts on the top, but the top is over here, and it would have moved right 1. So that's where I did that. But don't need to know that. I need to know, on your test, you need to know A's, B's, and D's. Okay, ready. Given this equation, we're going to find the info. So we're now working backwards. Okay, so here's what I'm going to do. Mid, top, bottom. I'm going to write this out for myself. Okay, so that's kind of what I always do. You can find your own method, but this is just kind of my thinking. Middle is where I basically start everything with. So what would you put into the middle of this? -3. Now I'm going to identify my amplitude, which is 5. So I'm going to have to think about, what if I was here and went down 5? -8. What if I was here and went up 5? 2. Okay, amplitude is 5. Midline was y equals -3. We identified those right away. Now that we did this, we can see our range. FYI, if your amplitude is 5, these should be 10 apart. Would that make sense? Why they're 10 apart? Right? And then our period. So I'm going to use that formula. 2 pi over b equals the period. So now 2 pi over, and then here's the b in the equation. This is the b. So 2 pi over 2. So your period would be pi. Okay, word problem. We have a Ferris wheel. Do we know how Ferris wheels work in real life? You can visualize it? So a Ferris wheel moves sinusoidally. I bet you've never thought about that when you ride a Ferris wheel before. So it is 60 feet in diameter. So 60 feet in diameter. What's the radius of this wheel then? 30. So it's got a diameter of 60. It makes a revolution every 80 seconds. Okay, so ready? I'm going to start at time 0 and I'm going to end at time 80. What would be the time of the ride when you're at the very top? 40. What would be the time when you're exactly on this side? 20. So 20, 40, 60, 80. Does that make sense with time? And the last piece of information here is that the wheel, the center of the wheel is 35 feet above the ground. So usually wheels aren't touching the ground. Hopefully your Ferris wheel doesn't scrape the ground. It's usually on a platform. So how much space is this right there? 5. Okay, so here is what a graph would look like. 20, 40, 60, 80, time in seconds. Height in feet. Okay, ready? You get onto this Ferris wheel. How much space are you off the ground when you're getting onto it? Right here is when you're getting on. So you're actually 5 feet off the ground right now. Okay, ready? Now you are on this side over here. So 20 seconds. What's your height off the ground right now? 35. And then when you are at the top, your height off the ground. So what are you right now? 60 and then 5. So 65. So look at that pattern. Okay, and then you could keep riding this Ferris wheel around. So I'm going to put an arrow on this side because I could keep riding the Ferris wheel. I'm not going to put an arrow on this side because I'm not going to go into negative time. Okay, you ready? We are going to grab our calculators. Okay, we're going to plot L1, L2. Do you understand your coordinates? So in L1, you'd be 0, 20, 40, 60, 80, 5, 35, 65, 35, 5. You see how they'd match your coordinates? Okay, so L1, L2, that's good. Give me a y equals screen, clear, activate plot. Okay, FYI, in sinusoidal, the stat edit stuff always has to be in radian mode. You can't be in degree mode for it. So you would have to be in radian mode. So we're going to zoom 9. There's our Ferris wheel ride, exactly what we thought. So give me stat, calculate, near the bottom. Actually, you know what I did? I went an up arrow because it's actually on the bottom. Sine regression. Enter, enter. Bless you. Bless you. Okay, you ready? Does this 30 make sense why it's a 30 in your equation? Yeah, because guess what we were doing? We were going 30 above the center of the wheel and 30 below, right? Does 35 make sense why your calculator got you a 35? Because that's right in the middle of our Ferris wheel. Okay, the question says, how long does it take for a rider to reach a height of 50? So I'm going to do a Y2. So we're going to have two answers. We can say it took this long for them to get to 50 on their way up, and then it can take them this long to get to 50 when they are on their route down. Does that make sense? On their way up, and then one time they'll hit it on their way down. So Y2, oh, I forgot to copy and paste it. Or did you guys already do that because you're ahead of me? See how we're all the same steps, right? If your window ever is doing slow, you can make your scales bigger. So looking at my scale, it's probably not that big, that's why. Second calc, intersection, enter, enter, enter. And then you can get me both answers would be good. And you can do that on your own with the same tools we did. I was getting 26.67 seconds to reach it on its route up, and then 53.33 to reach it on its route down. Okay, here's what I'm going to do. I'm going to add a question in here so that we can find another calculator maneuver. If I ever ask you, how long does it take you to go around the Ferris wheel? Okay, we know that it's 80, okay, but I'm going to show you how to get that answer. So how long does it take to go around a Ferris wheel? Would you understand that that would be called its period? How long to take you to go through a cycle is called your period on these graphs. And what's the formula for a period? 2 pi over b. So here's what I want you all to do. Can you go brackets 2 pi divided by, okay, and then did you notice that we had this b? This is the b. This was a, b, c, and d. This is the b, but you're not going to type 0.08. You're going to copy and paste it. So how do you copy and paste? Vars, statistics, equation, except for this time we're not copying the whole equation. What are we copying? Just the b. So now we just go down to here. And we should get 80 seconds to make a revolution, a period. So we're adding just one little extra thing with your calculator. You can 2 pi over b, and you can be copying and pasting that b right in there. Oh. Okay, how are we feeling? Do you want me, this is just similar stuff on the next page. I'm just doing periods, amplitudes, same kind of stuff. Yay more, or you want to try more? Okay. If you are like, oh, I totally get this, I'm ready to move on, you can just move on to your homework if you want. Okay, so on this example, midline is y equals 1. Okay, found it at the end. I need to go 2 above it and 2 below it because of the multiplier. So the top of it would have been 3 and the bottom would have been a -1. So now I can answer amplitude and I can answer range. And then the period is 2 pi over b, which is a 4 on that equation. There's a 4 in the b spot. And then the domain would go, domains go out, right? You just keep going and going on your waves. Okay, so again, this horizontal translation, I'm not going to worry about that. That's that C move. I'm not going to worry about it. Okay, graph, we're not going to do that because you could just plop that into your calculator. What mode, when you graph it, what mode would you put this one in? Radians. Okay, number 2 here, quickly we'll do this, and then mid, top, bottom. I'm going to have that idea always. So what is the middle of this one? Lauren's just shaking her head. There isn't one. So it is actually at 0. Whoops. Midline is at 0. Amplitude is 3. Which means my bottom and my top I can get. Okay, now let's go domain, negative infinity to infinity. I'm going to talk about the graph of this before we do the period of this. Graphing, what mode would you put this one into if you were to plot it? Look at your equation. What mode would you have to exist in? Degrees. So when I answer my period, I'm going to talk about degrees. Okay, so period is 2 pi over b, but I don't want to talk about 2 pi anymore. What's the replacement of 2 pi? 360 degrees is a circle divided by b. So this is a b. So it would only take me 180 degrees to make it through a cycle instead of 360.